I'm Gavin McQuillan. I'm from Squarespace, and so one of the things I should do is explain a little bit about Squarespace if you're unfamiliar. It's a platform that empowers millions of people, from individuals to local artists and entrepreneurs shaping the world's most iconic businesses. You've probably seen some of our adverts. So this is what we're going to be talking about. We're going to be talking about breaking up with Postgres. We're going to be talking about the Great Migration, lessons learned, and some closing remarks. So breaking up with Postgres. I'm a big fan of Postgres. I've been using it for decades. I've been using it professionally and personally. I've given talks about how to scale Postgres. It's a great system, and I'm a big fan. But why would I be advocating with breaking up with Postgres at my employer here? Well, for me, it was time to move on, and we'll get into why. So for our OLTP fleets, we're on an on-premise kind of deployed infrastructure. So we're running on VMs, and these VMs have a specific hardware configuration. This causes some constraints with like how much disk space do we have, and as these databases grow and grow and grow, we start to kind of have this like vertical scaling problem. So moving to the cloud would definitely help with a lot of this, but fundamentally all of these systems are on Postgres. They have a single primary. They are vertically scaled systems. And how do we handle things like sudden explosive growth? Tables grow larger and larger and larger, and the performance starts to suffer. This is a theme I think you've been hearing at these talks today. So we were thinking about, okay, we need to have a strategy for how do we not vertically scale, but how do we horizontally scale? So the other thing that we think about when we think about the future at Squarespace, we think about resilience a lot. We have a lot of customers. They're all over the world. There's hurricanes, freezes, power outages. We've had floods in which have caused us to have to move our data center. So that's a thing that we have to think about in terms of, preserving, are we still serving sites? Are we still able to, perform our job for our customers? We have put a lot of time into thinking about how to fail over from one data center to another. It's really hard, time consuming, and just doing those types of failovers with these primaried systems is not without risk, right? Sometimes things go wrong. So CockroachDB provides a platform for us that gives us very desirable recovery time objectives, which is something we're very interested in, and that's why we're doing these failover types of exercises. And the idea is that if you configure it correctly, your write should, if it's acknowledged, never be lost, even if an entire region goes dark, right? So the goal is we should basically be able to have these failover capabilities without ever having this manual work of us having all of our databases have the primaries move, that kind of thing. We're also interested in, I think many internet companies, right? We have a customer base that's all over the world. So global reach is really important to us. The replication primitives that make reliability so envious, I think, in the Cockroach system also makes it relatively easy to allow a seamless horizontal scaling across not only machines in different regions, but even potentially continents. Obviously, your application needs to adjust expectations, right? That's not the kind of thing we're going to spring on like systems that are currently running in Postgres. So you want to make sure that you're coordinating obviously with teams and with how you're ingressing traffic, but it's a possible thing that we can do now with Cockroach, with a distributed topology. Every company in the web wants to improve its global reach and provide better latencies to their clientele wherever they are. So that's something that's very interesting for us. And then sort of like the last tier of like problem space for us is complexity. Postgres is great. It's a beautiful code base. It works really well. It's been around a long time. But one of the biggest problems is running it. Philosophically, the project doesn't really make any decisions for its users. It doesn't want to be in the position to dictate how things work, right? Which is really admirable. I respect that. It's very philosophically pure. But it leaves all of the logistical problems, like how do you handle replication, backups, failovers, managing users, all that stuff is not really something that it has an opinion about so much. And so the community comes together and sort of fills that void with myriad of different tools. That really comes into as a problem when we're thinking about, okay, great, now I want to upgrade a major version of Postgres. All of your tools, all your auxiliary tools have to come with you, and hopefully they work together, right? So here's an example of what our kind of like a list of the different systems that we use to keep a Postgres cluster healthy. Obviously, we need these things to be upgraded when we upgrade Postgres, but some of these are actually interlocking, right? So like Rep Manager, which we use for replication management, actually interacts with PG Backrest, which is what we use for backups and archival. And so like these things also we have to make sure that they're version compatible with each other. And so it's kind of a big mess. And so little things like that, like where everything can be up and running, but you might not notice like there's something going on with your backup tool, right? Because it's not necessarily always running. And so it's a little surprise that you can find later. Visibility is another thing that we've noticed has been a big problem. There are tools to expose kind of what's going on inside of a Postgres cluster. You have access to things like Postgres statistics, you have logs, you can see currently running queries. But outside of like really expensive commercial observability tools, it's really hard for us to tell what's going on. So there was a particular point when the performance of the cluster was degraded. Which query was it? Which query ran that had that problem? Most people don't have access to those resources. And then lastly, upgrades is a part of this operational complexity piece. It's very difficult to get teams that you're working with. So in our case, we're a platform team. We're working with many other teams throughout the company, and none of them are very excited about potentially hours, maybe more than hours, of downtime to upgrade a large database, right? No one wants to say yes to that. It's very rare that people are just jumping at that opportunity. So it uses a bunch of the air budget for the system. It's difficult to get these important updates for not only the database, but sometimes even the underlying operating system. And so we're at kind of odds there. We're trying to maintain uptime objectives, but also kind of make security happy and get all of the nice updates that we want to have. So if all this complexity is so burdensome, why don't we just use a managed PostgreSQL system? So we have a little chart here, and like this is subjective. I made this chart, right? This isn't objective. So if you may disagree, but we wanted to be able to achieve not only a migration, to a new system, but one that like maintained kind of the goals that we have in an ongoing way. We came away looking at this and comparing like we could do managed SQL or Cockroach. We come away with the distinct impression that Cockroach provides the most value here. And some of the things we wanted to achieve aren't even possible on managed PostgreSQL, right? One of the most annoying things that I was just talking about, which is that you have major downtimes when we're doing upgrades. That remains unchanged in managed PostgreSQL, right? So it's really hard to scale your system and then still have an up-to-date system. So we did extensive load testing. We evaluated over a dozen horizontal scaling solutions. Most of that we evaluated by heuristics, so we didn't actually load test every single one of those. We brought it down to a couple. And we found that Cockroach is kind of the sweet spot where the system presents as Cockroach, as you would expect, but the topological information about like where does your data live, it isn't something that's forced for you to figure out how to put into your data schema. It's something that you can actually configure separately. So that means that the application team doesn't have to care about that. They don't have to like maybe do schema migrations to sort of define this data lives in this region and this data lives in this other region. It's something that you can actually do dynamically, which is great. The other bit here is that the console has become, for our team now, after we've done quite a few migrations, a daily driver. Just about everyone on our team is looking at it every day. We get a lot of insight into the health of our clusters and specific health of different code paths, right? So we get insight not only into the cluster, but actually into the entire system, which is great. So we can say like, okay, this query being run by this one API endpoint, it's having a high variation in its latency, and I wonder why that's happening. We can really investigate those kinds of things now, and it's a thing we never had any insight into before. So one of the biggest impacts for us right off the bat are these online upgrades, right? So as we're kind of transitioning to Cockroach, we have online upgrades. The other one is online schema changes. The number of times we have a team where they accidentally lock a table in their production database because they're adding a column or something, remarkably high. Happens all the time, actually. So this ability to do like online changes, both in terms of upgrading your binary and upgrading like basically the definition of a given table, some part of your schema, really has unlocked a lot of I guess, developer efficiency. We're not having as many incidents. So we can do quarterly upgrades without any downtime. We can help teams use these online schemas to prevent their accidental locking. And I think everyone's better for it. Okay, so let's talk. We've talked a lot about why we selected Cockroach at a very high level. Let's talk a little bit more about how we did the migration. You're probably interested in knowing a little bit more about that, so I'll tell you. For a sense of the scale, we had about 50 clusters in total to migrate. And we decided to only migrate systems that are in like our staging and our production environment. So if you consider like QA environments and sandbox environments and things, it's more than this, but for like live migrations, we only did this many. So it ends up being about 100 individual cutovers, and more if there's multiple attempts. So some systems we would cut over, do testing, and then cut back. And so this number might be a little bit low. I want to also like set some of the context for what a system looks like. It's a pretty vanilla looking system, but this is what a sort of service looks like at Squarespace. In general, most of our services are microservices written in Java, and most are backed by Postgres at this point. There's exceptions. We have other backing systems as well, but this is sort of a good kind of vanilla look at what we have here. Here you see that there's there's a few synchronous, a few asynchronous inputs. Our services evaluate requests and usually dispatch some amount of state management either to Postgres or to Kafka, Mongo in some cases, sometimes to caches. Mutations in Postgres are often republished, not always, to another Kafka broker cluster for inter-service async communication. So like business event kind of stuff, back-of-house accounting, that kind of thing. Like our issues with upgrades, we wanted to avoid extensive downtimes due to these migrations. So doing a cold migration would take many hours for our largest databases. So that entire system would be down, and that would be a big problem, potentially taking down traffic to multiple services at Squarespace. We needed something more streamlined. Dual writes would be a good option, but requires a lot of coordination with the applications team. And without the application being involved, we'd have some issues because doing a dual write at a proxy layer would be bad for us in the case that we're, say, generating IDs in the database layer, right? So then we'd have divergence between Cockroach and Postgres, and that would be no good. So I'll take you through kind of what our migration process looked like, again, at a high level, explained how we use change data capture, data validation, and proxies to smooth over these cutovers. So here's just a really simple diagram of that. We have syncing, data validation, proxying, and verifying the config, and then the actual cutover. And I'll dig into each one of these individually at a high level. So in phase one, we sync the data from Postgres. We're using change data capture to do this. So we use Debezium. We sync a schema over, and then we have Debezium do a snapshot, which copies all the data that it has in the current database, and then continues streaming the wall logs to a Kafka topic for us. We take that Kafka topic and read it, convert it on the fly, and then write it into Cockroach. And so this is a process that takes a while, can take hours, sometimes days. During this period, we often will pause the foreign key constraints on the Cockroach side so that the writes that we're getting for different tables from different transactions can go through a little bit more smoothly. We turn these back on before we actually move traffic over. Phase two, once our CDC streams have caught up, we start running data validation to ensure that data in Postgres and Cockroach are as much as possible exactly the same. It is a bit of a moving target as there's still streaming writes coming in. And then phase three, we move all the clients for a given service using our managed proxy. So we cut all of our services over to a proxy first. that proxy is going to be initially pointed to Postgres, and then it gives us a fulcrum really to cut over from Postgres to Cockroach relatively atomically. So when we're ready to do that cutover, this will be that point. And then this is sort of just a quick little visual of like what that looks like. We're using HA proxy kind of to do that part. So we just basically swap the backends when we rotate out the HA proxy containers in this case. Then phase 4, we prep for the cutover. This can be the most variable part of the migration. We're still validating our data in the background, right? We can still do that kind of asynchronously, making sure that our data is still good. But now we need to make sure our applications work with Cockroach, right? Where the data lives now. So we're going to be testing queries, making sure that indexes are correct, and helping teams set up load tests. Sometimes we'll do things, and so we saw some great notes from the FanDuel team, helping folks with their sequential keys, right? So if we want to convert your sequential keys to something more higher entropy, so that it spreads the key space over more nodes, it's something that we do before we do the migration. In those cases, we analyze indexes, we remove deferred constraints, or help people move those away, update libraries, set up all of the different things like TLS that they need to do to connect to Cockroach, and other small refactors. Phase 5, usually the shortest phase, and we want this to be short. We perform the cutover and observe. Usually we get a good idea of how things are going in a few minutes, but we observe for a few hours just to make sure that we aren't going to see some sort of latent or kind of occasional query load that causes some problems for us. Finally, after we've done this cutover and everything looks good, we actually set up a change feed now that takes the Cockroach stream of data changes and sends that to another Kafka cluster. We do this right after we've cut over our writes to prevent write cycles, and we use this in the event that we decide we need to cut back to Postgres. So if we find out in the next day or so that we need to have a performance issue, we need to cut back to Postgres, we'll have a stream of writes that have happened in the meantime. And so that's a single cutover. We do this twice for each application that we migrate. So once in staging and once in prod. It's a lot, but so much less than if we had to seamlessly migrate all of the lower environments. So we have dozens of lower environments, so we just do these two. So for those, if the data are required to be migrated, we actually use Molt for those. So we can just do a kind of a cold migration for those, and we're not doing a real-time streaming. So QA, that kind of thing, should be okay. Let me quickly go through the lessons learned. I think the first thing to say is I don't have everybody on my team. It's just there wouldn't be enough room on this slide to talk about all the folks who helped with this project, but our infrastructure teams are amazing. With 10 plus folks working on this, I couldn't be more impressed with their candor and their buy-in to the vision of taking all of our relational data systems and putting them into Cockroach. Super hands down, would definitely never undertake hundreds of migrations potentially without a team who is dedicated and sold on the vision and just really, really excited about it. I would say we hoped this would be true, and it turned out to be true, but 80+% of our clusters ended up being very straightforward cutovers, to the tune of very little work required, very little application changes. Great to see. Some applications weren't as easy, and that usually comes from systems that weren't designed to be distributed systems, right? Cockroach is definitely a distributed system, and applications can be a challenge to fix. So to get all of these benefits of Cockroach, we do have to work with these teams and try to convince them this is a good use of time and it's a good thing for us to spend time and energy on, and that the outcome is they get something that's very good for them in the long term. We find that kind of normalized tables, non-incrementing primary keys, things like that. If you find a database that's like that, usually we have had very good outcomes for them. So in cases where you can't avoid things like sequences, there's a few tricks that we found. Again, if you have vendor data in a database or something that we just fundamentally can't change, we can talk about some of those tricks later. But yeah, getting buy-in from teams is probably the hardest part. And it's hard to sell people when they don't see the biggest problems, especially when we talked about operational complexity. Um, running really short on time here, so I'm going to power through this as fast as I can. Yeah, so developers will take advantage of the new toolings. We've seen examples of people taking advantage of especially things like time traveling queries to undo kind of data validation problems in their production systems. And it's really great, and people taking advantage of the console and things like that. Cockroach has been a really great platform for them. Adapting to sequences, I just really wanted to touch on this really quickly. We have a thing in Cockroach called hash-sharded indexes, and that helps you basically split out writes to systems that do have sequences. It is a double-edged sword because it does cause a fan out for reads, so you're basically trading read performance for write performance, but it's something we've deployed. And then using read commit for pretty much all cases for systems that were developed in Postgres, we pretty much want to do this universally to avoid read after write types of errors that we see pretty frequently for systems that are expecting to kind of get that, to not have errors basically saying, please retry. There's been a change very recently. So we're on track to achieve our global reach, our horizontal scale. If a flood or a hurricane takes out one of our data centers, backed by CockroachDB, we can just pivot without losing a single write, and that's a huge benefit for us. We can keep up to date without taking our data systems offline anymore, and there's no more compatibility matrices because so many things are just built into Cockroach. It's a game changer for us. And I think in the meantime, we have these online schema changes that are a huge change that's going to improve people's CI experience. We can see a lot more that's going on with the console. Time traveling queries allow us to undo things at the application layer before having restore from a backup and then manually move that data into the production system. This is something that an application team can just do through a simple schema migration. And lastly, the security teams also are pretty interested in all of these changes. The seamless upgrades I've been talking about a lot. They love it too because we can avoid things like CVEs that are deployed in prod. We have MTLS for replication for all of our systems, and so not all databases are encrypted for the replication. And we have an event log, as mentioned before, so that we can basically track down who's done what kind of operation to the database when. And that's it. I'm out of time. Thank you all.